Multiplying monomials, lesson 4.1 notes. Example number 1, simplify. When possible, you're going to find the numeric value. So again, find the numeric value when possible. Okay, so remember, when you are multiplying powers, you add the exponents. So let's start with example number 1. Off to the side here, I want you to show the addition. So off to the side, let's put 2 to the 3 plus 4. You would not normally have to write that, but I want you to write it for your notes. Okay, so what is 3 plus 4? Well, 3 plus 4 is 7, so this would become 2 to the 7th. Now, can we find a numeric value from this? Yes, both the base and the exponent are a number, so we can go one step farther and find the numeric value of 2 to the 7th. Now, if you were using a school calculator, to get that exponent, you would use the caret button. All right, so the caret button is the button I have boxed there. If you look at my example in the screen, it's 3 to the 4th power. So I did 3 caret 4 and then hit enter. So if you're using the school calculator to put 2 to the 7th in your calculator, you would hit 2 caret 7. 2 caret 7 to get your answer. If you are using the calculator on the iPad, you're going to want to find, well, first of all, you would put in your 2, and then you want to find what has x to the nth power. X to the nth power, press that, and notice it gives you a box that you can put any exponent in. So in this case, I'm going to put in 7th. So 2 to the 7th power is 128. So for example A, 2 to the 7th is 128. Again, I added the exponents and then I just put it in my calculator. For B, well, if you notice on B, it doesn't have an exponent. When you have a base without an exponent, the exponent will be 1. So when you don't see an exponent, the exponent is 1. So again, off to the side, let's show what we would do here. We would take and add the exponents, so 1 plus 5. Well, 1 plus 5 is 6, so this would be 8 to the 6th power. 8 to the 6th power. So putting that in your calculator, 8, find your x to the nth button, or if you're using a school calculator, it would be 8 and then the caret button. Put in a 6, hit enter, and we get 262,144. For C, once again, let's write off to the side what it would be. We would take y and add the exponents. So this would be 2 plus 8. 2 plus 8 is 10. So this is y to the 10th power. Well, because the base is a variable, I can't go any farther. So this right here is my final answer. Y to the 10th is my final answer here. Any questions so far? Don't be afraid to send me a message and let me know. All right, let's go to D. So for D, off to the side again, we're going to put the k to the 5 plus 8. 5 plus 8 is 13. So this would be k to the 13th power. Once again, our base is a variable, so we are done. Our answer is k to the 13th. For E, instead of writing it off to the side, let's write it underneath. So this is going to be 7 to the g, we're adding the exponents, so g plus d. 7 to the g plus d. Well, can you simplify g plus d? Can you add variables that are not the same? They're not like variables, so no, I can't add them. Therefore, I am done. My answer here is 7 to the g plus d. And then F is very, very similar to E. I have a base of A, and I'm going to add my exponents, z plus 6. It is very, very crucial now that you put a line through your z. Very crucial. But now that we're going to be working with variables as exponents, also have 2's as exponents, you must put a line through your z so you don't get confused. Can you add z plus 6? Can you simplify that? No, you cannot. Therefore, my final answer for F is a to the z plus 6. Okay, that is it for example number 1. If you have any questions, please let me know.